My title was Prosumer 3D printers. Is it production ready? And I've been stuck in the negative naysayer, let's punch everyone we can session, which is good. It's probably the best place for this presentation. But I'm maybe not going to be quite as negative as previous comments. So what I want to do is talk about what the hell prosumer means, because again, it's a bit of a marketing wheeze. Talk about professional machines. I want to talk about consumer machines. The future, what does the future hold? Because I love the future. It's probably a lot better than the current and better than the past, definitely. And then what it means to companies, because I guess most of you are not garage inventors, most of you are not students, most of you are not hackers or makers, most of you are industrialists, you're business people. So we'll try and put it in the context of what change maybe means for business. And then, like everybody else, I want to do a bit of myth busting, but myth busting in the Econolyst way, which is you put metrics against myths, and then they become fact. So we'll do some myth busting at the end. So just to give you an overview, we're at a consultancy firm, as Duncan said. We've been around doing this for about 10 years, and our business is very much focused in the additive and 3D printing space now, and we're very clear what that means. 3D printing to us is a consumer process. It's either where consumers engage through the internet with professional technology, or they buy technology and put it in their own home. That's 3D printing. Additive manufacturing is an industrial process. It's where you use layers to make products. And they're two discrete things, and they have completely different markets, different customers, different channels, completely different. Most of our work's not in the UK, which is a sad shame and indictment of UK manufacturing. I've taken out the beautiful list and picture and all the people we work with, because there's too many of you in the audience, and I'll get pilloried, because then you'll find out which of your competitors we work for. So what do? We spend most of our time working with companies, helping them understand how you embed additive manufacturing in the supply chain. So how do you use this wondrous technology that we're hearing about to displace injection molding or CNC machining? And why would you do it? Where's the business benefit to doing that? Where's the economic benefit, the social benefit, the environmental benefit? And try and come up with reasonably cohesive plans for how you do that. Because of the exposure we get doing that, we spend a lot of our time now working with technology vendors, kind of trying to address some of the problems that Jez raised, which is, why don't these things do what I want them to actually do? Well, it's pretty simple, because we're moving faster than the vendors. We're trying to push them into manufacturing situations, and ostensibly we're taking prototyping technologies and trying to use them for things they were never invented for. Well, actually somebody needs to pass some of this back to the vendor community and help them work towards the technology. But bear in mind, 80% of the revenue that these guys make is still selling prototyping technology. So they're not going to fall head over heels to get into a manufacturing domain. And the other thing that we do, as has been mentioned earlier, is the investment community. The investment community is baffled by all of this. They're relatively baffled about the stock market valuations of some of the companies. There is an element within the stock market community about the hype cycle, the bubble, when's it going to burst, when do we get in, when do we get out? And what we try and do is put some sanity behind some of the claims. So prosumer 3D printing, that was the focus of all of this. Shall we have a willy, a bum, and a cock? I'm going to go to cock, okay? As far as I'm going, Jez, no further. So prosumer 3D printing, is it production ready? Great question to start with. What is prosumer? Everywhere I look now, some low-end technology vendor is selling a prosumer piece of technology. Actually, they've completely misinterpreted what prosumer means. It's not new. It's a 30-year-old phrase. It was first used by a guy called Alvin Toffler in 1980, and it was used in basically the height of the electronics boom. And what Alvin came up with was this term prosumer, and it meant aimed at the consumer using features taken from professional. So a prosumer camera, a prosumer VCR, prosumer video was actually all about saying, here's something for the consumer, but we're going to put a lot of technology into this that comes from the professional end. Actually, that's completely the inverse of what we have with prosumer 3D printing, because what we seem to be trying to do is take something that was developed as an open source RepRap project and convince you guys that it's actually ready and applicable to you. We flipped the use of the term around. So who's applying it? How are we applying it? I'm sure there was a big list earlier of all these companies out there who are in the consumer, the prosumer, the professional range. We tried to put some terms to this and sort of standardize what's meant. And I think a consumer 3D printer is a very, I apologize, I never usually have that many words on a slide. It's a very small footprint, simple to use, highly flexible system, dedicated software aimed at non-technical users such as children. And that's kind of where 3D positions the cube. Whether it fits in that position is another matter, but that's how they position a consumer printer. In the middle, I think there's a huge swathe of hacker hobbyist technology, largely open source, often assembled from a kit, non-specific software. You can usually run it off most things. You've got to be technically competent to use it. You need to have an engineering background. You need to have some electronics knowledge. And then you've got this wonderful thing at the top, this prosumer. And you kind of say, well, okay, what differentiates it? What is prosumer? Well, is it fully assembled, reasonable working envelope, multiple nozzles, dual extrusion, supplied with comprehensive software? I'm not sure. My definition is, put it simply, it's useful for consumers and it's useful for professionals. And that's pretty much it. So I think it's all a bit of a house of nonsense, in all honesty. So let me try and put some numbers to this theory. Earlier this year, we got approached twice. Two different companies came to us and said, we've got this idea. These consumer 3D printers, prosumer 3D printers, we think they can revolutionize our business, the way that we innovate and design products. Because at the moment, we've got these centralized rapid prototyping facilities run by that bloke, people like Jez Pullen, and they're dangerous people to have. So do we need these centralized RP facilities anymore? Because there's all this consumer RP. We can put it on our designers' desks. Yeah, and it will increase innovation. It will create innovative thinking. It will free up the design cycle. One of those companies has 600 design engineers. The other has 3,500. So if you're a vendor and a salesman, whoa, this is great. The car company's going to be putting them on their desks. So we said, yeah, I'll tell you what, we'll do a little benchmarking study for you. And they said, well, what are we going to print? And we said, well, we're going to print the things that your guys are printing today in your model shop. 10 real parts. Not things off Thingiverse, not things downloaded off Cubify, things that you actually make. So 10 real parts, and we'll do a technical and economic assessment. So we looked around the office, and we looked at the bits of kit that we have access to, and we said, tell you what, we'll do a very consumer machine, we'll do a 3D Systems Cube, a hacker consumer machine, an Ultimaker, we'll do a hacker consumer machine, a Rep 1, we'll do something very much sold as a prosumer machine, a Rep 2, we'll stick it on a Mojo, because that's an entry-level professional technology, and we'll put it through an EOS P395, because that is a professional technology and you certainly wouldn't have one in your house. And we'll look at a range of different materials. PVA, the good old PVA comes up again, it always comes up. ABS, color-changing ABS. Laywood, ABS loaded with wood. Glow-in-the-dark ABS. Whoa, it's great, glow-in-the-dark. Actually, just a little comment on the bottom there. One thing we did find is in 2 years, there have been more new materials for consumer printers than Stratasys managed to launch in 24 years. Now, that tells you something about open innovation, so keep that in mind as we go through the presentation, because it's a very changing dynamic that we live in. So, let's have a look at some parts. A door handle. There we go. So not the greatest resolution in the world, but there's a door handle made in PLA. Have we got a pointer anywhere? A pointer? I'll point. Top corner here. I'm not going to tell you which ones these are. Yes, I am. That's an Ultimaker made in PLA. So what do we use prototypes for in our businesses? Form, fit, and function. Is it functional? Nah. Form. Can I actually assemble it? Oh, all right. Well, fit. I can assemble it. Form. Does it look like I want it to look? Well, no, not at all. So as a professional prototype that adheres to form, fit, and function, is it any good? No. It doesn't actually achieve any of my requirements. Part of the side of it is off a cube. That's our very consumer 3D printer. Well, actually, get much better quality off a cube in ABS than we did off the Ultimaker. Same part, same orientation, same layer thickness, same slice. So no differences here. Nothing's changing. We're not going and doing it in Saudi Arabia. It's all the same. Now you find some interesting things here. This idea that, yeah, you can put these machines, a couple of thousand in your design office, because they're really cheap, and there'll be no increase in cost or overhead to the design and development department. It's not quite true. Because when you actually start looking at this, you get some really interesting stats. So our MakerBot Replicator 2, which is our prosumer machine, we had 2 failed builds before that part came out, because the software is not intelligent enough to tell us that it's not going to work. So actually, when we costed it up, it wasn't $22, because when we looked at where the builds occurred towards the end of the build, we'd already consumed about £10 of depreciation raw materials. What we didn't have to do was clean it up, and that's interesting, because in the economic model here, 20 minutes of cleaning time. Okay, well, if it's my 7-year-old son doing that, that's fine. That will probably cost me a Mars bar. If that is your, let's say, sculptural body in white design engineer on 60K a year, plus operational overheads, plus pension, plus company car, we've just taken it up to probably 130 grand. 20 minutes on 130 grand salary, do you really want him doing that? No, you don't. And this is where it all starts to fall over in terms of using the technology in the industrial domain. 3D Systems Cube actually came out better. The Ultimaker was great first time, but completely useless as a product. So we'll just share with you a few more. We looked at some other things. This was quite good. This was a full assembly. It was like 4 parts to a hinge assembly here. And we made them across a range of the tech again, and yeah, they're not that expensive as component parts. But what was interesting was the fact most of them didn't fit together because of the way they were made. So we couldn't actually use them as functional parts. In terms of assembly parts, they really weren't very good at all. Most of them weren't strong enough to use as a functional part. We tried to assemble them and to use them to actually open a latch, and they just broke. So, observation. In the hyped up world of 3D printing, prosumer is just a marketing term to sell products to professionals. Okay? These things are not prosumer. So another observation, Brie is a cheeky fibber. Okay? You cannot print everything. Okay? And if you walk around the MakerBot store in New York now, it's very different to what it was at Christmas, because at Christmas everyone walked around with t-shirts that said you can make everything. They don't wear those anymore. It's funny that. But that's enough of the naysaying. Positive thoughts. Positive industry. We're all happy. You know, it's not a MEMS show or anything like that. It's an additive show. Let's be positive. What if you designed the products to be made on the technology? So here's a flip, okay? What we're talking about here is trying to use a technology to make a thing. Because you need a thing, that's prototyping. And we've done it for 27 years. And there's some really capable tech to do it. Well, what about we acknowledge that these technologies are pretty limited and pretty stilted, and then we design things around the technology. It's called Design for Manufacture, DFM. We've been doing it for quite some time in molding and in CNC machining. So why don't we accept that there are design constraints in additive and work around them? So this is my absolute favorite design for manufacture example at the moment. This is a project that has been running around the internet for about a year called RoboHand. The background to this is a guy in South Africa. It's quite funny when you listen to him talk on the internet, because you just think you are the crappiest person I've ever heard talk about your job. Yeah? He's a joiner. He works with woodwork and he chopped his fingers off. Come on. Yeah, that's really not very good. But anyway, so you chop your fingers off and you're a joiner. What do? You want a robotic hand. You go on the internet, you live in South Africa, and you discover that they're 90 to 120,000 US dollars, and nobody in South Africa actually makes them. So you go on the net and say, I've chopped my hand off. Can somebody make me some opposable thumbs and I can actually function again? But I'm not really a techie. And what happened with the RoboHand project was somebody said, yeah, I'll help you. And the MakerBot guys got involved, and they gave him some MakerBots, and they developed a little gripping claw that this guy could use and articulate. And then the power of the internet, somebody heard about this, a woman heard about this whose son had something called amniotic band syndrome, which is an awful thing that unborn fetuses can get, where there's some sinew in the amniotic fluid, gets around limbs. When you grow, it doesn't move, and you lose limbs. It's about 90,000 kids a year born with it. And someone turns up and says, well, my son's got this amniotic band syndrome, he's got no hand. Can you apply that principle to him? And they said, yeah, actually, that's pretty simple. We'll redesign this with 4 fingers and a thumb, and we'll get you a working hand. And that's quite interesting. There's 90,000 kids with this. 7.5% are in G8 nations. So they're probably in countries that have got a healthcare system that would actually do something. 49% are in the G20. So, yeah, okay, they're probably okay. 51% are outside the G20. So they're probably in countries where there isn't a healthcare system that would do anything for them whatsoever. And they're probably not in a position of wealth parity to do anything either. There's 2 million kids with ABS, 10 million adults. So we kind of thought, well, okay, let ABS help ABS here. So what's it cost? So we downloaded the files off Thingiverse, we put them on the machines, we built them. It costs $10 to print all the bits. Okay, it costs $5 to buy the fixings. It's a pain in the arse, believe me, how many different components there are and where you get them from and how many bills you get from eBay. Reusable memory polymer. That's the stuff that's actually connecting to the human. Forget 3D printing, you're not going to do it with ABS or PLA. What you need is a proper medical polymer. It's about 25 quid for a piece of polymer that you can dip in hot water, warm it up, and wrap it around somebody's arm, the stub of their leg, and it will make a faithful representation. So forget trying to 3D scan it and print it out, pointless exercise, far quicker to just get some memory polymer. They take 10 hours to print, 3 hours to assemble. We reckon there's 100,000 consumer 3D printers in the world already. 188% year-on-year growth. You could actually just deal with this whole issue of ABS by 3D printing these parts. It's kind of nice. Nice, uplifting, warming story of something you can really make, because I'm trying to be positive in the negative session. So, what does the future hold? Well, I'm going to set this one up. printmeamilanvelocevic.com, because apparently you're going to be able to do this, so we may as well have the website now. If you've seen The Fifth Element, apparently you just print beautiful-looking Russian women. It's really easy. It's all done deal. The world's changing, and we have to acknowledge this. Absolutely have to acknowledge that in the last 5 years, 2 years, 1 year, the world has changed. Okay? And in our little world of additive, and it is little, it's tiny, there are some really big things happening. One is technology route to market. If you came to TCT 15 years ago, some of the companies had websites, some of them probably didn't. Did any of them do e-blasts? Probably not, and if they did, you'd probably try and sue them because you'd think, what the hell was that? Did any of them use Facebook? No. Did any of them use Twitter? No. Most of the new technology coming to market uses new media channels, new marketing channels. That's where it's coming from. That's where it's coming into the world. Unfortunately, for shows like this, it's not necessarily where it's coming from. If you're trying to innovate, do you have to go and employ really expensive people anymore? No. You use open source, open innovation models like GrabCAD. Access to finance, and there was a comment earlier. Kickstarter, Indiegogo, you don't go to venture capitalists, you go and see if the market wants what you're offering. Has anyone seen just out of show of hands, anyone seen the new 3D printer on Kickstarter that uses water to control the Z-axis? Yeah? Finally, after all these years, somebody's genuinely invented a new additive manufacturing process, not a rehash of an old one. So go and have a look at Kickstarter, type 3D printing, there'll be lots of them pop up, usually extruding bits of plastic out of nozzles, and just the same as the last one, just a little bit cheaper and faster and better and whatever. This one is $100, it's got no stepper motors, there's no PLC, there's no logic controller, it just has a little tub of water, and you float the resin on the top, and then you position your optics above it, and your optics moves up and down with the water. And then you plug the optics into the headphone jack on your laptop, and it moves. And then there's a little sensor that controls the water level you plug into your microphone jack. And that's it. Game over, finished, done. One 3D printer. So this is where innovation seems to be coming from. And removal of barriers, Creative Commons, and removal of patents. There's about 12,000 additive patents out there now. And a lot of the early stuff is falling off the end. And actually, I think what we're going to see is a lot of the follow-up and secondary patents that people filed in order to try and extend the life will probably get challenged because they aren't innovative steps beyond what was in the original first patent. So it's an interesting world that we're in, and it is changing. Of course, other things are happening at a corporate level, such as the very large marriage that took place or is still taking place. I don't know if it's taken place or whether the party's going on or whether it's a long extended bar mitzvah, I'm not quite sure. But other things are happening, and they're really quite interesting when you look at them and you say, well, why are these things happening? Yeah? I showed you some of the parts off that MakerBot earlier. And you look at it and you say, well, why do they look like that? Why is the quality as the quality is? Why is it as weak as it is? Why is it that Stratasys comes out like that and MakerBot comes out like that? And there's a few things. In terms of quality, soluble support material, patented by Stratasys, owned and maintained by Stratasys. Heated build envelope has a massive implication on the quality of the lamination. Extruder design. Most of the extruders that people are using on home 3D printers have been hashed together. Nobody's thought about the science. Nobody's looked at the rheology of how the polymer is actually flowing against the nozzle. What metal did you make the nozzle out of? Well, I got a bar of brass. Okay, well, have you actually looked at the polymer chemistry of pushing molten ABS across brass? Yeah, there's actually an enormous amount of friction. It's really not the right material. Why haven't you used stainless steel? Oh, stainless steel. Yeah, so there's a lot of thinking that comes from companies that have been doing it for 27 years and software that actually works. And then, what do you get the other side of the marriage? You get some really interesting things. Open innovation culture. I'll come on to that with MakerBot. It's really interesting, kind of where they've come from and where they got to in a short period of time. Rapid innovation management. This risky approach of actually putting things in the market that aren't maybe ready, but if you market them in the right way, so if you ever saw the marketing for the MakerBot Replicator 2, they put a warning symbol on their marketing saying, this will probably not do what you expect it to do, but it's really good and you should buy one. So they did address it by kind of putting a dinosaur on there going, ah! And from a marketing perspective, it probably sold machines, because they're actually saying it's a bit risky, this thing, it's a bit dangerous. Community engagement, again, something we've seen hugely growing in the last couple of years. And street credibility. I cannot believe how you described somebody earlier, Jeremy. There's street credibility, and then there's outright slander. Capability. This is kind of interesting, yeah? If you map out the history of a company like MakerBot, in 2008, 2009, they were basically part of the RepRap community with Adrian Bowier, playing around with simple, cheap, allegedly self-replicating, but never going to be self-replicating machines. And then they commercialize it, and they make their cupcake, and then they realize that, yeah, okay, people don't want things with wires hanging off the back, you have to assemble themselves. And they come up with a Thingimatic, and they say, well, we'll put them together for you, or you can still put it together yourself. And then they come up with a replicator and said, look, you don't really want to put it together, we'll put it together for you. And then they say, but you don't really want something that looks like a tea chest with some holes in it. We've got some money now, by the way. Let's sit down and engineer something. So they come up with the Replicator 2, and then they realize that there's a few issues with this in terms of thermal control and management. So then they come up with the 2X really quickly. And what's interesting is the innovation cycle gets quicker and quicker and quicker every time. 18 months, 14 months, 10 months, 4 months. Yeah? And now you're mashing that up with a company that's brought 7 materials to market in 28 years. This is kind of the way the world's going. The other thing is prices are tumbling, whether we like it or not. And somehow we have to kind of get our heads around this. If you look at a Viper as a really good example and look at a Formlabs machine, there is fundamentally not a lot of difference in the accuracy and resolution. It may not be as quick, but at, what's that, 2% of the price, 250K compared to 3.2K. Very different world order emerging. MC400 against Gigabot. The Gigabot's bigger than the MC400 in terms of build envelope. Profactory machines against B9 creators. The whole dynamic is changing. Materials, this gets really fun. Stratus ABS is $297 a kilo. ABS from MakerBot's $48. If I go to Sabic and ask how much it is, if I buy more than a ton, it's $2.50 a kilo. And then if you phone up some converters and say, I've got a couple of tons of ABS, I want to turn it into a 0.175 millimeter filament, how much does it cost? And they say, oh, by the meter or by the kilo. You say, by the kilo. They say, it's about two US cents conversion. Right, okay. It's big changing world order. Same with photocurable materials. You know, they do not cost $400 a kilo. So what am I trying to say here? What I'm trying to say is that if you map all this out, we're actually in a point now where we've got convergence. We've got technology convergence. So if you look at the moment, you've got kind of cost at the bottom, high cost and low cost. Things are too expensive for some people, they're absolutely fine for others. Cost is coming down. In terms of consumer machines, it's going up. It's getting more expensive. If you look at the cost of the MakerBot 1, the MakerBot 2, the Ultimaker 1, the MakerBot 2, Printerbot, Printerbot Junior, they're getting more expensive. Okay, that's fine because they're getting more capable. And if you look at the professional technology, it's kind of marginally getting a little bit cheaper year on year, but not very much. And its capability is going up pretty slowly. So at some point, we will see some convergence between professional and consumer. I'm not going to put a date on it or a year on it, but I don't think we're in the decades mode out there. I think we're within the decade. So what does it mean for you guys, mainstream manufacturers, this potential future convergence? We did a study earlier this year, which was super, super good fun, with IBM, and they're fab IBM because they've got really deep pockets. And they came and said, right, we're going to do this study. We do studies every year because we're IBM, and we think that the world's going to change. And the bit of IBM that came to us was the consumer electronics part of IBM. So these are the guys who tell Foxconn how to do manufacturing in the future. And they go and tell Apple how to put phones together and where to put them together and why to put them together. And they came and said, we think that in 10 years' time, there's going to be 3 fundamental changes in the electronics industry. One is advanced robotics, things like that little guy there, Baxter, $20,000 robot, who's basically a teach-and-play robot that can go on a production line next to people. He's got full sensing around him. If you get near him, he just stops and waits. And then when you go, he carries on doing what he was doing. And actually, when you look at him, his purchase price is less than the minimum wage in some countries. And they said, well, what's going to happen when Baxters are everywhere, and you put them with 3D printing technology that's ultimately flexible, and you put it with open source electronics? So if you're not familiar with open source electronics, this is all about things like Arduinos and Raspberry Pis and Android. This idea that you don't have to be a monolithic electronics company to actually make electronics products anymore. So what happens when you put these three things together? Do you change the way that products are brought to market? So with IBM, we worked with a few companies on a few products, Bosch, Samsung, Philips, Apple and Starkey, and we looked at their supply chains, and we looked at their bill of materials, and we looked at, well, okay, well, what could you 3D print today? What could you conceptually 3D print? What would the economics of that 3D printing be? What would the technical limitations be? What would the carbon footprint be? And what would a future supply chain look like? And the way that we did it was in a very analytical, methodical way. The first thing we did was we said, well, let's look at intellectual property. How does that constrain the market? How is it holding back innovation? And when does it fall off the end of a cliff? And when will other people be able to come to market and compete against others with innovation? And we then said, okay, well, what about technology development? What's going to change in the next 10 years? How is technology going to change moving forward? And we did some really interesting stuff here for futurology. We looked backwards. So we went to the vendors and we said, can we have the stats of the machines you were selling 15 years ago? And people like Stu Jackson were more than open and went, yeah, there you go. That's the state of the art of an EOS laser sintering machine 15 years ago. And then we said, have you got it for 5 years ago? And have you got it for now? And then we did some mathematical modeling and developed some curves and said, actually, do you know what? The rate of progression really isn't as grandiose as everybody thinks. And then we said, well, why? Where were the step changes? Was it changes in laser power? Was it changes in optical systems? Was it changes in polymers? And what's the likelihood of those changes happening again? And we were able to develop some quite neat curves, I think, in terms of where the tech would be and the productivity, and that was the key issue. So we looked at how it would change productivity and economics, and then we looked at how it would realign supply chains. So this idea of you redistribute manufacturing, you put it near the point of consumption. Well, what does that mean? Is that really realistic? Why are you going to do it? Well, you're going to do it because it's environmentally friendly. You can't ship things from China. That's a dreadful thing to do. Well, actually, that's complete nonsense, because if you don't load a ship up, if it's above its peninsula line, it actually uses more fuel than if you load it, so you're going to put ballast on it anyway. So we looked in a lot of depth about the economics and the environmental implications. And then we worked with some great guys in the States called SourceMap. And SourceMap are kind of, you can only describe them as forensic engineers. If you give SourceMap a product, within a couple of weeks, they'll come back with a full bill of material and tell you where all the bits came from. We use them quite a lot to work out whether the vendors are telling fibs about the number of machines they sell. Because we can find out how many print heads they bought, because it's usually on a manifest roster somewhere in New York, because they get them from China or Japan. So SourceMap will tell you how much an iPhone costs, bill of materials, component parts. They'll even tell you where everything comes from. So we worked with SourceMap to map all this out. And then we kind of looked at the whole impact. If we develop future scenarios, how will it change society? So we kind of looked at IP protection, material cost, hardware costs, scan speeds, print head capacity. That's a fascinating one, print heads. You'll see some super tech out there on the 3D and the object stand, or the voxel jet if they're here. Amazing technology, amazing. But it's actually using very old print technology. So we went and looked in the 2D printing industry, which is where we nick all our print heads from, and looked at the state of the art in 2D printing. And the state of the art 2D print head can jet out about 10 times more material than the state of the art that we've got out there. And if you look at how long it takes for us as an industry to adopt their technology, it's about 5 years. So it doesn't really take a brain surgeon or Jez to work out that in a few years' time we're going to be at a position where we can implement that tech into printhead technology. So we did some wonderful road mapping, and I'll share some bits with you. So a washing machine. Would you 3D print a washing machine? Because it'd be great if you could, because if you live in a little cottage, you could have a little one, and if you've got kids who poo a lot, you could have a big one, and if you're students, you could have a really tiny one. So we modelled this. It's interesting because the bill of materials for a Bosch top end, and this is top end, 1,500 quid washing machine, is $310 for the piece parts. The value of the non-3D printable parts, if you segment them all out, is about $235. So we can only at the moment displace about $75 of the BOM. And that $75 would cost us about 12,000 quid to print. using today's technology. So are we going to 3D print washing machines? No. Moving forward, if you keep the same component parts, then in 5 years' time it comes down quite dramatically because of printhead technology development. Move on a bit further to 10 years, you don't actually see much more of a slide because the component parts that we looked at, we'd already driven the cost out. The hearing aid, very different with the hearing aid. It's about $313 is the bill of materials for a hearing aid. It's quite interesting here. $310 is non-3D printable. The bit of a hearing aid that's 3D printed today, which is the shell, and we've heard all about this, you know, most of the world's hearing aids are 3D printed. Those shells cost $3 to make. You do an economic model on a stereothography machine, depreciate it over 10 years, look at the resin consumption, overhead, electricity, labor, boom, 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 boom. They're $3 to make. Okay? So, moving forward, what happens if we get rid of stereothography and use little Formlab machines on the high street? Yeah? Because that's distributed manufacture. Well, it doesn't do anything. Because all of the cost is still in the non-3D printable part of the BOM. Amplifier, speaker, microphone, integrated circuit. You go forward 10 years and it starts to change quite a lot. Because that's when we start to see the 3D printed electronics starting to come to fruition that guys are researching today. So if you look at the state of 2D printed electronics, we can already print a battery in 2D, we can already print a speaker in 2D, we can already print a microphone in 2D, we can print circuitry in 2D. So within 10 years, yeah, there's no reason why that sort of thing won't be 3D printable. And then you do see the bill of material change massively. Because from all the modelling that we've done, looking at printhead systems and material cost, the cost comes down to about $12, and you've displaced $200 of your BOM. So it is quite an interesting dynamic. So what have we learned, if anything? Well, there's a lot of hype around. New world order, bigger than the internet, you can print anything. Just dispel some myths, I said we do some myth busting. A certain vendor made a comment on a financial news channel in the USA that 3D printing is bigger than the internet, or will be. Okay, that's how big the internet is. That's 3D printing, okay? So there's about 60,000 home 3D printers, 30,000 commercial 3D printers in the world. That's probably up to about 100,000. The internet has 2.4 billion users already. So lots of opportunity. If you do a bit of modeling and give it to the modeling guys, the point of convergence is actually 2025. So if you're a hedge fund thinking that the world's going to change because of consumer 3D printers, yeah, okay, you might have to kind of go long on some of your stock. 3D printing, 4 years in, it's about a $100 million market if you value it out from machines and materials. 188% year-on-year growth is what we've monitored it at. That puts it at about $15 billion by 2020 through organic growth, which sounds great, doesn't it? It's going to be bigger than the internet. McKinsey valued the internet last year. It's a fantastic report if you read it. They look at the economic GDP value of the internet. If the internet was a country, it'd be about $8 trillion. And that was 2 years ago, compared to a $15 billion industry in another 8 years' time that hasn't happened yet. So is it bigger than the internet? Absolutely not. So let's just put that one to bed. Let's just keep it real. So I think that was all I wanted to ramble through. My hangover's gone. So if nothing else, I feel better.